To extend the learning rule for a linear neuron to a learning rule we can use for multi-layer nets of nonlinear neurons, we need two steps. First, we need to extend the learning rule to a single nonlinear neuron. And we're going to use logistic neurons, although many other kinds of nonlinear neurons could be used instead. We're now going to generalize the learning rule for a linear neuron to a logistic neuron, which is a nonlinear neuron. So a logistic neuron computes its logit, z, which is its total input. It's its bias plus the sum over all its input lines of the value on an input line, xi, times the weight on that line, wi. It then gives an output y that's a smooth nonlinear function of that logit. As shown in the graph here, that function is approximately 0 when z is big and negative, approximately 1 when z is big and positive, and in between it changes smoothly and non-linearly. The fact that it changes continuously gives it nice derivatives which make learning easy. So to get the derivatives of a logistic neuron with respect to the weights, which is what we need for learning, we first need to compute the derivative of the logit itself, that is the total input, with respect to a weight. That's very simple. The logit is just a bias plus the sum over all the input lines of the value on the input line times the weight. So when we differentiate with respect to wi, we just get xi. So the derivative of the logit with respect to wi is xi, and similarly, the derivative of the logit with respect to xi is wi. The derivative of the output with respect to the logit is also simple if you express it in terms of the output. So the output is 1 over 1 plus e to the minus z, and dy by dz is just y into 1 minus y. That's not obvious. For those of you who like to see the math, I put it on the next slide. The math is tedious but perfectly straightforward, so you can go through it by yourself. Now that we've got the derivative of the output with respect to the logit and the derivative of the logit with respect to the weight, we can start to figure out the derivative of the output with respect to the weight. We just use the chain rule again. So dy by dw is dz by dw times dy by dz. And dz by dw, as we just saw, is xi. dy by dz is y into 1 minus y. And so we now have the learning rule for a logistic neuron. We've got dy by dw, and all we need to do is use the chain rule once more and multiply it by de by dy, and we get something that looks very like the delta rule. So the way the error changes as we change a weight, de by dwi, is just the sum over all the training cases n of the value on an input line, xin, times the residual, the difference between the target and the output and the actual output of the neuron. But it's got this extra term in it which comes from the slope of the logistic function, which is yn into 1 minus yn. So a slight modification of the delta rule gives us the gradient descent learning rule for training a logistic unit.